Disc Lecture 5C, Concurrent Programming with WorkQ. In this lecture, you'll learn about WorkQ, which is a concurrent programming framework for massively parallel applications. WorkQ scales up to millions of tasks running on thousands of machines for complex applications in science and engineering. To create a WorkQ program, you write a custom master program in a general purpose language like C or Python or Perl, and link that against the WorkQ library. Using that library, you create tasks, where each task consists of a command line annotated with the input and output files needed to execute that command. This allows you to build up a large concurrent application from existing tools that are standalone executables. To learn more about WorkQ, please visit the link at the bottom of the page, which has lots more information. The WorkQ webpage has all of the technical information that you'll need to download the WorkQ software and start writing applications. If you scroll down here, you'll see that there's a detailed user's manual. There is API reference information, so you can learn about all the function calls. There's an example program in C and in Perl and in Python. And you can also download the software or visit our forum to get help. Let's review the architecture of a WorkQ program. The part that you write in the upper left-hand corner is simply called the application. And the job of the application is to define and create tasks which can then be submitted to the WorkQ master library. The WorkQ master library will hold on to those tasks until it has a worker on which they can execute. And then it will read the necessary files and programs off the local disk and send them to a worker to be executed. Now that worker has a local directory, which is a cache of commonly used items, and those files and other dependencies will be put into that cache directory. Then for each task to be executed, the items will be linked into a sandbox directory so that the task can execute. If you have a worker managing a large number of cores in memory, then multiple tasks may execute simultaneously if they all fit in the single worker. As the tasks complete, their results are sent back to the application, which can then consume the results and possibly run more tasks. Here's the outline of a typical WorkQ master application. We begin by including WorkQ.h to bring in all the necessary library definitions. Then we call WorkQ create to create a new instance of a queue listening on a particular port number. Now we create some tasks. For each task we call WorkQ task create and the command string that that task is going to run. And then we'll make a few extra calls to add some details to the task. When the task is fully specified, we submit it to the queue. Now that can repeat as many times as you have tasks. And once you've created all the tasks you need for the moment, then you call WorkQ wait. WorkQ wait transfers control to the WorkQ library and causes tasks to be dispatched to workers and work to be completed. And whenever a task is completed, it will be returned as a result from WorkQ wait. If that result is non-null, you have a task done, so you can do whatever you need to do with the results and then delete the task. And then from there, you can go back and submit more tasks, or you can wait again. WorkQ is an example of a submit wait API. You can see right there, we submit tasks and then we wait for them.